According to the given data, we have drawn this circuit diagram which consists of two resistances 10 ohm and 24 ohm connected in parallel, and across this a cell of EMF 3 volt is attached, which is having its internal resistance as 4 ohm. As we can see, I have labeled this circuit diagram as points A, B, C, D, E, F, A, so that we can consider the different loops while solving this problem. And as you can see, this cell of EMF 3 volt is giving out the current I. So at point F, this current I is going to be split up into two parts, that is I1 and I2. The part I1, it will flow through the branch FC, whereas the part I2 will flow through the branch FABC. That is, at junction F, current entering the junction is I and current leaving the junction is I1 and I2. Therefore, according to Kirchhoff's first law, we can write total current I is equal to I1 plus I2. Now, for finding the values of I1 and I2, we are going to consider different loops. So first of all, we are going to consider a loop A, B, C, D, E, F, A. So therefore, we can write in loop A, B, C, D, E, F, A. This is the complete loop. So in this loop, now we are going to apply Kirchhoff's second law. So according to Kirchhoff's second law, as you can see, the current is flowing from point A to point B, and the direction of tracing of the loop is in the same direction. Therefore, we can add, this is nothing but minus 10 I2 from point B to D. We are not having any of the component. Again, from point D to E, in between we have this 4 ohm, and the direction of tracing of the loop and direction of flow of current I is in the same direction. So we can add, this is nothing but minus 4I. Now we are moving from negative terminal of the EMF, source of EMF, to the positive terminal. Therefore we can add, this is nothing but plus 3, and from E to A no component is there, so this is equal to 0. Therefore we are going to get, this is minus 10 I2 minus 4I is equal to minus 3. Therefore we can write this equation as 10 I2 plus 4I is equal to 3. Assume that this is, say, equation number 1. Now we are going to apply Kirchhoff's second law to the next loop, that is F, C, D, E, F. Therefore, we can write in loop F, C, D, E, F. F, C, D, E, F. So we start from the point F. So from point F to C, the direction of flow of current and the direction of tracing of the loop is same. Therefore, we can write, this is nothing but minus 24 I1. Now from C to D, we are not having any of the component. From D to E, we have this 4 ohm internal resistance of the cell, and the direction of flow of current I is same as that of the direction of the tracing of the loop. Therefore we can write, this is nothing but minus 4I. We are moving from negative to positive terminal of the cell, so we can add, this is nothing but plus 3. From E to F, the loop completes, so is equal to 0. Therefore, after solving this, we are going to get minus 24 I1 minus 4I is equal to minus 3. Therefore, we are going to get, this is nothing but 24 I1 plus 4I is equal to 3. We will consider this as equation number 2. Now from equation 1 we can write, from equation 1 we can add, this is 10 I2 plus 4I is equal to 3, but we know that I is equal to I1 plus I2, so we are going to substitute the value of I in this equation. Therefore we can write 10 I2 plus 4, in place of I we can write I1 plus I2, so this is I1 plus I2 is equal to 3. Therefore, after solving, we are going to get 10 I2 plus 4 I1 plus 4I2 is equal to 3. Therefore, we get this is nothing but 14I2 plus 4I1 is equal to 3. Consider this as equation number 3. Similarly, from equation 2 we can write, so we will write from equation 2 we can substitute the value of I is equal to I1 plus I2 in this equation. Therefore, we can write 24I1 plus 4 into bracket I1 plus I2 is equal to 3. Therefore, we can write 24I1 plus 4I1 plus 4I2 is equal to 3. After solving it, we are going to get this is nothing but 28I1 plus 4I2 is equal to 3. We will consider this as equation number 4. Now, by using equation 3 and equation 4, we are going to find the values of I1 and I2. For that, we are going to multiply this equation 3 with 7. Therefore, multiplying equation 3 by 7. 4 into 7, that is 28I1 plus 14 into 7, that is 98I2 is equal to 3 into 7, that is 21. Now we are going to subtract this equation 4 from this equation. Therefore, we can write this is minus this equation 4 as it is, will write. So 28I1 plus 4I2 is equal to 3. Due to this subtraction, the signs will change. So this will become minus, this plus become minus, and this will also become minus. Therefore, after solving this, we are going to get this is nothing but this will get cancelled, and we are getting this is 94I2 is equal to 18. Therefore, from this we will get I2 is equal to 18 upon 94. From this we can write this. Therefore, we can write I2 is equal to, after solving this, we are going to get this is nothing but 0.1915 ampere. So this is the value of current I2 which is flowing through the branch AB, that is through the resistor of 10 ohm. Now, in order to find the value of I1, we will substitute the value of I2 in equation 3. Therefore, from equation 3, by substituting the value of I2 in this equation, we can write this is 4I1 plus 14 into 0.1915 is equal to 3. So therefore, we are going to get this is nothing but 4I1 plus this is 2.681 is equal to 3. Therefore, we can write this is 4I1 is equal to, we'll shift this side, so we are going to get this is 0.319. Therefore, I1 is equal to 0.319 by 4. Therefore, I1 is equal to 0.0798 ampere. So this is the value of current which is flowing through the branch FC, that is through the resistance of 24 ohm. Therefore, now the total current I, we can find it as I is equal to I1 plus I2. So just we are going to add these two values, that is I1 and I2. Therefore, after adding these two values, that is I is equal to I1, that is 0.0798 plus I2, that is 0.1915. Therefore, the value of I, that is total current flowing through this branch DE, we are going to get this is nothing but 0.2713 ampere. So I1, this is the value of current which is flowing through the branch FC, that is through the resistor of 24 ohm. current I2 which is going to be flowing through the branch AB, that is through a resistor of 10 ohm, and current I is equal to I1 plus I2, that is the total value of current is 0.2713 ampere is going to be flowing through the branch DE, that is through a 4 ohm resistor. In this problem, we want to find current flowing through the galvanometer of resistance 10 ohm. We are given with the 4 resistances 5, 10, 20 and 15 ohm, which are connected in a circuit, as you can see in this circuit diagram. Total current I, that is 2 ampere, is flowing through this entire circuit. Now we have labeled the circuit as A, B, C, D. At point A, when current I reaches, then at point A it gets split up into 2 parts. So some part of the current will flow through the branch AB and some part of the current will flow through the branch AD. Say I1 is the current which is flowing through the branch AB, and say I2 is the current which is flowing through the branch AD. Now at point A, when this current I1 will reach, then some part of this I1 will flow through the galvanometer, which is denoted by, say, IG. So IG is the current which is flowing through the galvanometer, means through the branch BD. But the current flowing through BC, it is nothing but I1 minus IG. I1 is the current which will reach at point B. Out of I1, the current IG will flow through the branch BD, and the remaining current, that is I1 minus IG, will flow through the branch BC. Now at this point the current I2 will reach. So in this branch, as we can see here, so this IG will come at point D and I2 will come at point D. So the total current flowing through this branch BC, it is nothing but I2 plus IG. So when these two currents will reach at point C, that is I1 minus IG, which is flowing through branch BC, will come at point C, and the current I2 plus IG flowing through the branch DC will reach at point C, and again we are going to get the total current as I. Now for finding the current flowing through the galvanometer G, that is nothing but IG we want to find. So for that we are going to consider a loop ABDA. Therefore from this loop A, B, D, A, we start from point A. From point A to B, the direction of flow of current I1 is in the same direction of tracing of the loop. So we can write this is minus 5 I1. When we are moving from B to D, the direction of flow of current IG is in the same direction of the tracing of the loop. So therefore minus 10 IG. From D to A, the direction of flow of current is opposite to the tracing of the loop. Therefore plus 15 I2 is equal to 0. Therefore we can write this is minus I1 minus 2 IG plus 3 I2 is equal to 0. Let this equation say equation number 1. So this is our equation number 1. Now we are going to apply Kirchhoff's second law to another loop BCDB. Therefore for the loop BCDB, here you can see when we are moving from B to C, the direction of flow of current, that is I1 minus IG, is in the same direction of tracing of the loop. So therefore we can write this is nothing but minus 10 I1 minus IG. Now from C to D, the direction of flow of current is in the upward direction and we are moving in opposite direction. Therefore we can write this is nothing but plus 20 I2 plus IG. And here when we are moving from D to B, the direction of flow of current, that is IG, is in downward direction from B to D, and we are tracing the loop from D to B. Therefore we can write this is plus 10 IG is equal to 0. Therefore after solving this we are going to get minus 10 I1, minus minus becomes plus 10 IG plus 20 I2 plus 20 Ig plus 10 Ig is equal to 0. Therefore, we are going to get, this is nothing but minus 10 I1 plus 40 Ig plus 20 I2 is equal to 0. So from this we can write, therefore this is nothing but minus I1 plus 4 Ig plus 2 I2 is equal to 0. We are dividing this equation throughout with 10. So this is one of the equation. We are going to assume this say as equation number 2. But at point A, the total current entering the junction is I and the total current leaving the junction is I1 and I2. Therefore, by applying Kirchhoff's first law to this point, we can write, but I is equal to I1 plus I2. But we know that this I is nothing but 2 ampere. So therefore, we can write 2 is equal to I1 plus I2. Therefore, we can write I1 is equal to 2 minus I2. Now we are going to substitute this value of I1 in equation 1 and equation 2. Therefore, from equation 1, we are going to substitute this value of I1 in this equation. Therefore, we can write, this is minus sign as it is. For I1, we can write 2 minus I2 minus 2 Ig plus 3 I2 is equal to 0. Therefore, we get minus 2 minus minus it becomes plus I2 minus 2 Ig plus 3 I2 is equal to 0. Therefore, we get this is minus 2 plus this becomes 4 I2 minus 2 Ig is equal to 0. Therefore, from this we can write minus 1 plus 2 I2 minus Ig is equal to 0. We have divided this equation throughout with 2. Therefore, we can write this as 2 I2 minus Ig is equal to 1. So we will assume say this equation, say equation number 3. Now similarly from equation 2 we are going to substitute the value of I1 in this equation. Therefore from equation 2 we can substitute this value. So we can add this minus sign as it is. For I1 we can write 2 minus I2 plus 4 Ig plus 2 I2 is equal to 0. So therefore we can write minus 2, this minus minus becomes plus I2 plus 4 Ig plus 2 I2 is equal to 0. Therefore from this we can write minus 2 plus 3 I2 plus 4 Ig is equal to 0. Therefore from this we can write this nothing but 3 I2 plus 4 Ig is equal to 2. We will consider this say as equation number 4. Now we are going to make use of equation 3 and equation 4 for finding the value of Ig. So we will multiply equation 3 with 3. So therefore equation 3 is to be multiplied with 3 and equation 4 we are going to multiply with 2. Therefore we can write this equation multiplied by 3. Therefore we can write this is nothing but 6 I2 minus 3 Ig is equal to 3. Now multiplying equation 4 with 2 we get 6 I2 plus 8 Ig is equal to 4. Now we are subtracting this equation from this, so we'll take subtraction, so these signs will change, this become minus, and after solving this will get cancelled and we are going to get minus 11 Ig is equal to minus 1. Therefore, we will get Ig is equal to 1 upon 11. This is the value of current, that is Ig, which is flowing through a galvanometer of resistance 10 ohm, which is 1 by 11 ampere.